Michelson interferometer, model number Nvis 6115. It is based on the principle of interference. In this experiment, we have a base plate, two stands to attach the laser and the Michelson interferometer unit, and one is beam splitter to split the beam in two parts. This is based on the principle of interference, in which when we incident the laser beam on a beam splitter, with this beam splitter it splits into two parts. In this and in Michelson interferometer there is a movable mirror. One beam goes to mirror and another one reflects from the beam splitter. During reflection they got merged, and due to their merge the path difference creates, and due to that path difference the interference pattern generates. This is the principle of Michelson interferometer. Now we start the installation procedure of this unit. First of all, we will insert this rod to base plate. Here is screws are given by which you can tighten the rod. Second rod, to tighten the rod with given screws on base plate. Now take the Michelson interferometer unit, place it on rod given. In this Michelson interferometer unit, there is a kinematic mount which contains a mirror and a translation stage to count the number of rings. And here is a beam splitter. You have to put like this. The reflecting surface should be your side. And now you can tight it with this support. Now take the laser beam, place it on these base plates. Here is a switch given to on the laser. Now switch on the laser and align it perpendicular on the lens, which is provided here. When laser beam comes on lens, from lens it goes to beam splitter, and from beam splitter it goes to mirror. Beam splitter splits the laser light in two parts. One goes to this mirror and second one comes to this reflected surface. And from here and here two waves are going, reflecting waves are going, which are shown here too. We can see two spots of reflecting waves. To get the interference pattern, we have to merge these two spots in one. Here is the two screws are provided on kinematic mount. Using these mounts, you can merge these spots, and starting to merge it. Here are the screws. Using these screws you can merge two spots. You can see two spots are merging together. Now these spots are merged and become one spot. If you are not getting the ring, you have to check the alignment of lens, beam splitter and mirror. You can align it or by these assemblies or simply by laser. I am starting to align it with laser. You can see when the proper alignment happens, we can easily got the interference rings. Here are the rings showing on wall. And the laser, you will get the interference pattern which is shown here. You can also adjust these fringes with the help of X and Y screws which are given on kinematic moment. And for counting the number of fringes, you can use these translation stage. By using this translation stage, you can count the number of fringes also. So here is the experiment of Michelson interferometer for getting interference pattern for the wavelength measurement of laser. Thank you very much.